Students, this is the second set of notes in the astronomy unit. They are called Astronomy Part 2, the solar system. Just like the other notes, on these notes you're going to write down what you see in orange text. If you'd like to write down something else, of course you may, but the only requirement is to write down or type what you see in orange text. And this is going to go in your notebook on page 16. So the solar system begins with the sun. As we learned in the first set of notes, the sun is the energy source for everything that happens on Earth. Like our Earth, the sun has layers. You don't have to memorize all of these, but you should know that the sun has a core right now, and know that it also has an outside layer called the corona. So the sun is the star at the center of our solar system. Most stars have at least one planet. The sun plays a huge role in Earth science, and all of the energy on Earth comes from the sun. Inside the sun, nuclear fusion is taking place. Fusion is when two atoms combine to form a larger atom. Inside the sun, hydrogen atoms are fusing into helium atoms. This nuclear fusion releases a large amount of energy. And here is a diagram of nuclear fusion, two hydrogen atoms fusing together to form one helium atom and releasing energy and a neutron. So the solar system is full of celestial bodies. A celestial body is anything floating in outer space. The solar system consists of many types of celestial bodies. Our sun is one of them. Then there's 8 planets. There's dwarf planets, thousands of comets, and millions of asteroids, all just in our solar system. And you don't need to draw this right now, but you will be expected to be able to draw the solar system from memory, including all the planets, the asteroid belt, and the Kuiper belt, which is the outer belt of rocky debris. Here's another version of the solar system that contains dwarf planets. Pluto, which used to be a real planet, and some of them have just kind of funny number names like 2003 UB313. Ceres is the dwarf planet in the asteroid belt. So what is a planet? A planet is a massive celestial body that is round, orbits a star, and has cleared its area of debris. Earth is the third planet from the sun. The 4 closest planets to the sun, including Earth, are called terrestrial planets or inner planets or rocky planets. The 4 outer planets are called gas giants, the outer planets, or the Jovian planets. And the gas giants are way bigger than the terrestrial planets, which are the 4 smallest planets shown in this comparison. So for the terrestrial planets, you need to know that they're small, rocky, solid, and more dense. They're closer to the sun and generally warmer than the gas giants, which are bigger, gaseous, less dense, and further from the sun, generally cooler than the terrestrial planets. So all planets rotate and revolve, and you need to know the difference between rotation and revolution. So rotation is planets rotating on their axis. The rotation on their axis causes the days and nights that we experience on Earth, and all planets have days and nights, because 50% of the planet is always illuminated by the sun, and the other side is dark. So this axial rotation causes days and nights on Earth and on other worlds. And that picture there, that's a flat image of what it looks like when it's summer in the southern hemisphere. If you flatten out the globe, 50% of it is lit up and 50% of it's dark. But on a flat map, it looks a little different than as a sphere. So revolution is the motion around the sun. All planets revolve around the sun. The time it takes for one revolution of the Earth around the sun is 1 year. So rotation is spin, and that causes day length, and revolution is orbit, that causes the year. So each planet is different, and you can measure different aspects of the planets. Each planet has a unique density, a unique day length, and a unique year length. Um, Earth is the standard of comparison for orbital period. So we talk about other planets' years in terms of how many Earth years is it, and day length. So like if you look at the chart here, a length of a day for Jupiter is 0.4 Earth days. So it spins faster than Earth. But the orbital period for Jupiter is 11.9 Earth years. So it takes 11 years for Jupiter to go once around the Sun. So the terrestrial planets are Mercury, Venus, Earth, and Mars. Mercury is the closest planet to the Sun. It has a slow rotation but a quick revolution, meaning its days are very long but its years are very short. It has no atmosphere, a densely cratered surface. Being close to the Sun means that it's in the path of a lot of things moving, and there are no moons for Mercury. Venus, the next planet out from the Sun, is considered Earth's twin. They are similar in size. Venus is very hot because it has a dense atmosphere which causes a runaway greenhouse effect. Venus is the second brightest natural object in our night sky. Venus has long days and short years, and it also has no moons. We live on Earth. Earth is the only planet with life and the only planet with water, and it has one moon that you should be familiar with. We're going to talk a lot about Earth this year, so we don't spend a lot of time talking about Earth during the study of astronomy and the solar system. But Earth is the only planet with the internet, and the only planet with squirrely fries. Boom. All right, Mars. Going outward from the Sun, we've done Mercury, Venus, Earth, now Mars. Mars has a reddish tint from the iron in its crust. It has a very thin atmosphere. It has ice caps of solid carbon dioxide, and there has been evidence found of liquid water on Mars, which might indicate that it has once harbored life. The asteroid belt is an area full of space rocks between Mars and Jupiter. The space rocks can be millimeters or kilometers in diameter, so ranging from very small to very big. But an asteroid is too small to be considered a planet. There is one dwarf planet in the asteroid belt. It's called Ceres. So an asteroid is a space rock orbiting the Sun. A meteor is a space rock in Earth's atmosphere, and a meteorite is a space rock on the ground on Earth. So the same rock can go through all of these phases. When it's floating in outer space, like in the asteroid belt, that space rock is an asteroid. If it moves out of the asteroid belt, it actually becomes a meteoroid. And then as it travels into Earth's atmosphere, it becomes a meteor, and that's also known as a shooting star. And then if it hits the ground and it's found, then it's a meteorite. All right, the gas giants, also called the Jovian planets. We've got Jupiter, Saturn, Uranus, and Neptune. Jupiter is the largest planet, the size of over 1,000 Earths. It has a giant red spot, which is a storm. It's larger than our planet. And the storm has been raging for more than 300 years. Ever since people could get a close look at Jupiter, they've noticed the red spot, which is a storm. Jupiter has currently 79 confirmed moons, and that number's going up as new objects are sighted. Saturn is known as the ringed planet. It has 82 moons right now, but that could go up. It has the fastest winds on the solar system. It is the least dense planet, and it takes almost 30 Earth years to orbit the sun, and that's a revolution. Uranus was not discovered until 1781, so moving out from the solar system, all those other planets are close enough that they could be seen either with the naked eye or with um, a simple telescope. Uh, Uranus, when technology advanced, when telescopes got better, people could see further out, and Uranus was discovered. Uranus rotates on its side at a 90-degree angle from its orbit. It has a faint ring system that's vertical. It has 27 moons, and it is the coldest planet. Neptune was discovered later in 1846. It's even further away. It is the furthest planet from the sun. It takes 164 years to orbit, Earth years that is, and then it has 14 moons, including the largest, which is called Triton, and that's bigger than Pluto. And of course, Pluto used to be considered a planet, but it's not anymore. This is just a device that some people use to try to remember the planets. Mercury, Venus, Earth, Mars, and then your thumb would be Ceres / the asteroid belt, and then Jupiter, Saturn, Uranus, Neptune, and then your other thumb would be the Kuiper belt. I personally like the mnemonic device. My very educated mother just served us nachos, and just remember that the asteroid belt is between Mars and Jupiter. So the Kuiper belt is an area beyond the orbit of Neptune, containing asteroids, comets, and dwarf planets, including Pluto. Pluto was once considered a planet, but it was later reclassified as a dwarf planet. You see, what happened was they found several other Pluto-sized objects, and they either had to make them all planets or demote Pluto, and they decided to demote Pluto, so don't feel bad. It's still very important. Even further beyond the Kuiper belt is the Oort cloud, which is another collection of icy objects in the outer parts of the solar system. The last thing we're going to talk about is comets. A comet is a celestial object consisting of a nucleus of ice and dust, and when it's near the sun, it gets a tail of gas and dust particles pointing away from the sun. The tail points away from the sun because of solar wind. So here is a collection of everything from these notes that was supposed to be written down. So pause the video here and catch it up if you need to. Of course, you can handwrite it or type it up. It belongs in your notebook. This is going to be page 16.